know that there's going to be 50 or 200 or 2 million. I mean, there's no way to scale that from the beginning. So then analysis, design, development, testing, implementation, and maintenance again. And you could, well, then after that we got to sort of a recurring waterfall, so you could go back one phase if you wanted to. So you could keep going back, but of course that too was a bit silly. But many companies worked along this method. So you shouldn't forget that this was the way software was built until 1990, 1995. And then the first company started experimenting with this going, why after 2 years have we built something that nobody wants? Because that would happen a lot. Lots of people were building things, and then in testing phase already customers were saying like, yeah, but this is not really what we need. This is what we needed maybe 3 years ago, but now business has changed. So what are we going to do? Are we going to adjust, or are we just going to deliver and see what happens? Well, those kinds of questions. So Agile Methods, this is sort of where software development for me got kind of exciting, because the old dinosaurs, my own professors, were talking about the slow, well-planned development and the way in which these requirements have to be written down in very strict formats. Big document generation machines, basically. People writing, but not writing code. So, and then Agile Methods came by, and I think most of you are still thinking, I hope you're still thinking the same way as I was back then, thinking, well, if I just got 3 guys in the room, we would not write 1 letter of documentation. We would constantly, be throwing paper at each other's heads and having fights about how the architecture should look. But we wouldn't be writing down those decisions. We'd just be, and that's probably how you think too now. Of course, my image has changed, because I've seen companies with 100 developers, and then you can't, throw around paper balls anymore and just go like, oh, this is how we're going to do it, and simply, make decisions by who has the loudest voice. But by that time, it's a little bit different. But right now, so this was very, how do I say it? User-friendly, so to say. So to me, this sounded so much better, because Agile was, okay, we deliver something in 2 weeks, we see how far we get, and then the customer can say, that's not quite what we need, let's go a little bit more right, let's go a little bit more left. And then sort of you're converging towards a working system. Whereas with the waterfall way, you would go for sort of a big bang release, and then the customer would go, yeah, not what I need, thank you, and we'll buy it, but we'll just leave it in a drawer somewhere. Whereas Agile was more, okay, every week or every month you'll have a meeting with the customer, and the customer will look at your software and say, yeah, that's what we were looking for. Or maybe it's still a little bit buggy, let's take another month. Downside of this, of course, is that it can be quite hard to plan, because you don't know what's going to happen next month. Well, we'll get to into more details. Yeah, so, well, I'm not going to go too deep into this, because I have a whole talk about requirements engineering, but the idea is that you can, for instance, at the end of every iteration, so you see iterative development consists of a series of tiny projects. So at the end of each iteration you can say, okay, the requirements are now the following 50. And we can only implement 20 around about, say the developers, so let's do that. And then in the month you see you'll only implement 15. But the bottom 5 may have completely changed again. So, now you have a new prioritized list, and those 5 maybe have dropped to the bottom. So it doesn't really matter that you missed those. Or maybe the customer says, ooh, those were way too important. They should have been at the top. Well, now I'm already heading towards Scrum, but we'll get to that in a minute. So then RAD came out. RAD was sort of before or around the Agile Manifesto, and I think, so does anybody know here the Agile Manifesto? No? Alright, good. So a little bit of history. At some point the developers of RUP, we'll get to that in a minute, RAD and some other developers, they got together and they said, okay, we want to stop with this crazy waterfall method. We want to develop some guidelines to help people get through software projects quicker, and also get people to gain some more respect for the software sector, so that they understand that this is really a hard business, and getting to the right type of system is not a trivial problem. It's something we need to work hard for. So one of the guys who invented RAD also was on that committee. They created the Agile Manifesto, and you can still go to the Agile Manifesto page and sign it, or maybe the signing in is now closed, but I know my name is on there somewhere. And the one cool thing that RAD did was involve an end user, or involve a customer, usually on a day-to-day basis during development. So every day you'd have someone to bounce your ideas off and go like, okay, if you were to use a system, how would you do this? Or if you see this interface, is that what you were looking for? So for me, the Ladyside product, I developed that from a, how do I say it, from the point of view of a customer, somebody who would be using this on a day-to-day basis. And therefore, I'm sure that it's better than your average product developed by somebody who's not involved in the process. And of course, lots of prototyping, and this is something we'll talk about more later. But you can imagine that prototyping isn't easy in some cases. So think, for instance, about right now. I recently purchased the Pebble watch. Does anybody know Pebble? It's a watch that connects to your iPhone or Android phone, and it's a hardware product. And you can already imagine that prototyping a hardware product is very expensive. Because every time you have to get the hardware, and then you have to implement all that into a sort of a robust little device, and then you have to have people carrying it around for a month and saying, it's crappy, it doesn't do this, it doesn't do that. So that's really hard to prototype. So you can imagine that for software, it can be really easy to prototype, but as soon as there are hardware components involved, it's a little bit tougher. So there you can already see that for some type of products, such as hardware products, prototyping and rapid development might be less suitable. So think, for instance, about the iPhone. Of course, on the software side, everything could be easily developed in a sort of rapid prototype way. But on the hardware side, well, there's lots of things to think about. So if you are building an iPhone, well, what are concerns you would have if you're constantly trying to, let's say you have 6 months to build iPhone number 5. What are your main concerns in those 5 months? And you want to have maybe 3 or 4 different versions. Somebody tell me? You're Steve Jobs or whoever followed him up? Not you? You're already thinking the good things. I know, I'm sure the right answers. No ideas? All right, so what are the risks? That's, of course, what we're afraid of here. So one of the first things is cost. You want, every time a new version, getting, so mass production is cheap, single production is really expensive. So every time you send it to China and say, hey, here are our designs, try to produce this and see how far you get. Well, one of the things will be that the Chinese party will go, okay, well, we'd love to build it, but you made some mistakes. So it's not going to work in your current configuration. So you're going to have, it's going to cost a lot of time. What else could happen? When you send over your designs to China, what is everybody afraid of whenever you send anything to China? Exactly, they steal your ideas. That was it, very good. Yeah, no, so that's one of your problems. So you want to keep the knowledge as inside as possible. So maybe you want to get some type of hardware simulation, and of course there are many hardware simulators out there. So, consider that, for software it's easy, for hardware it's a little bit harder. Might be an exam question, especially because it's a great way of thinking about it. Alright, so here you see some fundamentals of RAD. I don't know the differences between the different methods, but what's interesting about this is to know sort of, okay, which method added which idea. So RAD, for instance, the rapid prototyping and lots of prototyping, that came from RAD. Actively involve system users, and do it in an interactive and iterative construction approach. We're going to talk about this more later, but can anybody tell me what a great way would be to get requirements with, well, how can you win requirements? Can somebody tell me this? No idea? Yeah?
You mean how you can get a list of requirements?
Yes.
The next way would be to talk to potential users.
Yes, talk to potential users. Okay, that's one. What was that?
In systematic manner.
Okay, well that's interesting. That's for the next class. So talk to potential users. All right, give me one more.
Look at the competition.
Oh yeah, very nice. Yeah. Yeah. And one that's related to that is market analysis. See where the market is going, because then you know that some requirements are quite soon popping up. Okay. But think about the end user. How could we, if we were to develop a system, a new Osiris together, what would be a good way? So we've looked at the competition, we've seen Osiris. What else could I do? Or what could you do? Okay. Many blank stares. One guy tapping on his phone.
You could just look at Osiris and say, well, if it's in Osiris, we won't do it.
Ah, so go for reuse, you mean?
Yeah, no, we won't do it because it's Osiris Osiris. So if it's in Osiris.
Ah, right. Okay, so to see what not to, learn what not to do. Well, okay, I'll put that in market analysis. So another thing you can do is do, how do you call it? Sort of mock-ups. So that's an important one too. Start with a mock-up. And just show some people a PowerPoint in which you've created some screens and go, hey, this is what we're thinking about. What do you think? I could even show you some mock-ups later, but I don't think we have the time already.
But that's really the same as involving potential user, right?
Yeah, but I mean these are just structured approaches. So one other thing you could do is well, let's add it also as a focus group. So a focus group could be a meeting like this where we all sit together and I say, okay, what's wrong with Osiris? And what are the base functionalities that Osiris should do from our point of view? And then we can completely change it. Any other good ideas? No? I don't know. I mean, the list is, I think, 10 items long, and you have to know about 8 from me. Well, we'll get to that later. Yeah, so iterative construction approach. So, like I said before, one thing that I want you to remember is that as you're doing it in an agile way, well, let's say this is T, and time is progressing, and let's say this is sort of 1. This is bliss. This is where we all want to be. If we can get to this level, then the product completely matches. So let's say if you do waterfall, then you could have, after 8 months, you can have this big bang release, which is, well, not close to your final what you want. Whereas if you do it in an iterative way, well, you'll see that your first release will be maybe here, your second release will be maybe here, your third release, well, you didn't make very much progress. But as you can see, you're sort of well, let's say you'll never get to the truth, but at least you have this progressive line. Whereas with these slower releases, well, you can imagine that here you have a big bang, here you have a big bang, and here you can already see, well, this product is probably more successful because you're converging more towards the truth. That's an important picture I want you to have in your head. All right, so extreme programming. Well, I think I already talked about this iterative development, but in these quick iterations. And what's quite cool here is that they're not showing it yet, but you could even sort of put these together so that by the time you're busy with design, you already start planning anew. So some of the people who were planning before or writing requirements, they start writing requirements again because, well, as soon as the development team starts doing things, the product manager or requirements engineers, they can keep doing their job. So it's sort of continuous, as you can imagine. Well, and like I said, one of the things that's really important about this very first picture, let's see if we can go all the way back. Yeah, this picture is, so I have this theory that the quicker this goes, the more feedback you'll have, the quicker you can converge to the truth. So that's really important here. So if this cycle takes 2 months, you're never going to be as quick as Google that releases every week. Or Facebook, which also tries to release, I think, on a weekly basis or so. So that's a really important point I want you to be aware of. So then there's the RUP. RUP is sort of this nice mix for true managers. So RUP was invented at IBM, no surprise there. And RUP is also for those managers who still want to go, okay, we are iterative, but we are still very, very structured. RUP is, I think, described in a 100-page document saying exactly how you move through the different phases. And well, here you see some gates, some quality gates. And here you already see a little bit of the waterfall. So RUP is taught to me as though being a mix. I have no experience with RUP, being a mix between Agile and waterfall and being a little bit closer together. But you can already see, very incremental. Philippe Vluchte is one of the people who worked on this method, and I've been in at different conferences with him. And one of my students once attacked RUP without knowing that Philippe was in the room. And well, it was an interesting meet between the two. There was one, I can tell you. So Scrum, well, Scrum is I think the most popular method now. I think Erik Huisman may have even told you that they use Scrum, because they do. And Scrum is basically, well, small teams do small pieces of deliverable software using sprints or 30-day intervals to achieve an appointed goal. And Scrum really works in the way that you say, okay, at the end of so like I described before, you start off with a really nice list. So of prioritized requirements. Let's say you have 8 requirements, you have 1 developer, and you say, well, within 2 weeks I can deliver this set of requirements. So then you deliver it, and then here's the next release, so 5, 6, 7, and 8. Then you get here, 5, 6, 7, and 8. But the customer decides, that 8 is important, but actually it's not so important. So let's drop it to the bottom again. But here we have 9, 10, 11, 12. Very important lesson here, lists of requirements usually grow, they never shrink. And now you could say, okay, well, as a developer, in this case again, I can only do 4 requirements, so I can only deliver these. And then you see, hey, here's yet another version. And then they say, well, 10 was actually not as important as we thought, we'll just scratch it, so there won't be any 10 anymore. There will be 11, 12, 14, 13, 8, well, and you can imagine then it just continues again, and again the developer will say. Now you can see some requirements, they fall off the list, they disappear. What's of course makes this a little bit more important or more interesting, and we'll talk about that later too, is when you start saying, well, this is 4 hours, this is 1 hour, this is 22 hours, this is 16 hours, and you already know what I'm going to do next, this is 4 hours. And of course you only have 40 hours in 1 week, so let's say you have 1 week to do all these. Well then of course it becomes very tempting to say, yeah, this one might be really important, but this is what we can finish. So let's move this one to there. So it's these kinds of planning problems that you get later on, and well, we might still be able to cover them in this class, maybe not, maybe we will. Really interesting. Oh, and important about the Scrum is the Scrum meeting. Every morning you start with a 5-minute stand-up meeting. It's a stand-up meeting because when developers stand, they don't like standing, they want to sit, so they keep it nice and short. And each of you says, okay, well today I had this and this problem, or you say use the traffic light system. I'm on green, all systems are go, or I'm on orange. I don't quite know how to architect this particular part. Or you're on red, you say, I need the specifications from the customer right now, and if I don't get them, I can't work. I'm just sitting on my ass. So that's what the stand-up meeting is for. Now stand-up meetings here, it says, I think, begins with the stand-up meeting. So there's sort of this belief that it should only be 5 minutes, but I've heard stand-up meetings lasting at least half an hour or sometimes longer, typically about 15 minutes, and very useful. Can anybody tell me what the main challenge for a stand-up meeting is in a large software company? No? Alright, makes sense. It's quite hard. It's outsourcing. What if you outsource half your work to India? What do you do? And what if you want a mixed team? What if you want 2 guys from India, 3 guys from the Netherlands in one team? How do you make sure that they have a stand-up meeting? It's a lot harder, as you can imagine. Alright. Well, so here's the Agile Alliance Manifesto. I already talked about it. So, some beliefs here, some of those statements. Early and continuous delivery of valuable software will satisfy the customer. Obvious. Changing requirements are welcome, so they're not a threat. Like in the waterfall method, you saw those 7 phases. So everything that's been decided in the first 3 phases determines the execution of the rest of the phases. But of course, if after half a year business changes or VAT goes from 19 to 21%, what do you do? So those are challenges we're going to talk about. Business people and developers work together. So you